This is lesson 5.2, and I'm going to be doing it in two parts, so this is part 1. The name of this is probability distribution. So a few definitions. Random variable. It's a variable, usually x, that has a single numerical value determined by chance for each outcome of a procedure. So remember, with randomness, every subject within the population has the same chance of being part of the study, right? So a random variable is the same idea. Now, probability distribution is a description that gives the probability for each value of the random variable, often expressed in the format of a table, a formula, or a graph, okay? So that's how we see probability distribution, usually as a table, a formula, or a graph. Now, discrete random variables, this is a collection of values that is finite or countable. So we did talk about this before. Discrete just means that you have a beginning and an end to your values, okay? Then there's also continuous random variables, and this has an infinite amount of values, and the collection of values is not countable. So it just keeps going on. It's not possible to have a set number of values. We did talk about before how, like, if you looked at a certain segment of it, then you could make it discrete. But anyway, we're going to be mostly focusing on discrete in this chapter. So there are requirements in order for this to have probability distribution. The first requirement is that the numeric random variable, it has to have a numeric random variable like x, okay? The second one is the sum of the probabilities within that study have to equal 1. And then lastly, all the probabilities have to be between 0 and 1. In other words, they're decimals, okay? They have to be between 0 and 1. Notice that those are less than or equal to symbols, which means it can equal 0 and it can equal 1, and it's just fine. Okay, so those are the requirements in order for it to be probability distribution. Now, let's just say that x represents the number of girls in 2 births, okay? So this right here is a representation of that. We could have 0 girls in 2 births, 1 girl in 2 births, or 2 girls in 2 births. Now the probability of each of those is written 0.25 for 0, 0.5 for 1, and 0.25 for 2. The question on this, does this represent probability distribution? Well, x is random. The reason why it's random is because you can't determine whether or not you're getting a boy or girl each time there's a birth, right? Every child born has the same likelihood of being a boy or girl. So yes, it fits the first rule, x is random. The second one, the sum of all the probabilities has to equal 1. If I add up 0.25 plus 0.5 plus 0.25, I get 1. And usually we just write it as 1.00. So that fits that rule. The probabilities add up to be 1. The last one, each value of the probability has to be between 0 and 1. 0.25 is between 0 and 1, right? 0.25 is in between 0 and 1. 0.5 is between 0 and 1, and 0.25 are between 0 and 1. They're not greater or less than 0 and 1, so therefore it fits the rule. Okay, so this does fit probability distribution. Now, one thing to point out, guys, sometimes you'll remember how we had probabilities like 0.000023 whatever. Well, technically, if we rounded this 4 decimal places, we end up with 0 probability. Although 0 probability does not really reflect the probability accurately, because there is a very, very, very small chance that could occur. So we'll often use the symbol 0 plus to represent the fact that there's basically a 0 probability, but there is a slight chance that it could happen, so we put the plus on there to represent something like that, okay? So that's just to point that out. Now, look at the other table there. If this is a poll asking subjects if marijuana should be legal, your own personal views aside, you'll see that X has yes, no, and I don't know. And then you have your probabilities. And it's asking, is this probability distribution? Well, is my X values numerical? Well, these are not numerical responses. So already this fails probability distribution. So that can't be probability distribution. However, now this is just to point it out, the sum of my probabilities, if I add these together, I do get 1. And are the probabilities in between 0 and 1? Yep, all these are decimals. So therefore, it fits the other two rules, even though it doesn't fit the first one, but this is not probability distribution. All right. Let's give us an equation and see if we can determine whether or not it has probability distribution. So the probability of X is equal to X over 3. When X can be 0, 1, or 2. Alright? So it's asking, does this just determine probability distribution? Well, first thing I want to determine is whether or not it's numerical, right? The probability of 0 is 0 over 3. The probability of 1 is 1 over 3. And the probability of 2 is 2 over 3. This would give me 0 as an answer, this would give me a decimal answer, this would give me a decimal answer. They're all numerical, so therefore, so far it passes probability distribution. Now, do they add up to be 1? Well, since these all have the same denominator, we add the numerator. 0 plus 1 plus 2 is 3 over 3, which is equal to 1. So yes, they'd add up to be 1. Finally, is P of X in between 0 and 1, with 0 being inclusive? Well, this would give me 0 as a decimal answer, this would give me a decimal answer, and this would give me a decimal answer. So they are all between 0 and 1, so this is probability distribution. Now, parameters. A parameter, these are common statistics. So the ones that we're going to mostly focus on are mean, variance, and standard deviation. Okay, so those are the main parameters that we're going to talk about. It's just the way that we show our distribution, okay? So let me give you a few rules here. The mean, I can never draw the symbol very well, that's mu, pretend, is the sum of X times the probability of X. This symbol right here, that stands for variance. The variance is the sum of X minus mu, that's the mean, mu is the mean, right? Squared times the probability of X. Another way to look at this as well is the sum of X squared times the probability of X minus mu squared. Mu, once again, means the mean. So this is the mean. Finally, this symbol right here without the square on it means standard deviation. And that is found by the square root of the sum of this equation right above it. X squared times px minus mu squared. I can't draw mu. Anyway, there you have it, okay? Pretend that's mu. Alright, so this is how we're going to find each of our parameters. I'd love to keep them up there, but unfortunately I need to delete them or erase them so that we can solve, so we can show some examples. Now there's one other thing I want to talk about. It's called expected value. Expected value is the value that you would expect to get within the information, okay? So there's a formula for expected value. Just so you know what the definition, it's the average or the mean of what we expect to get if the trials could continue indefinitely. Alright? For example, if you're flipping a coin and you only do it 50 times, you're probably not going to get 50-50 on the flipping the coin. However, you continue going on 1,000 times, you're probably going to get closer to 50-50 than you would if you only flipped the coin 50 times. So anyway, expected value, what we'd expect to get if it could continue indefinitely. So expected value is represented by capital E. Capital E is the same as mu, which is the mean. So the way we would solve it is the sum of x times p of x. We just barely saw this rule because this is mean. That's what expected value is the mean. So anytime you're finding expected value, you know that what you're looking for is the mean. Alright, so find the mean, variance, and standard deviation of the number of girls in 2 births. So here we go. We're going back to x here. We have 0, 1, and 2 chances of births with 2 kids being girls. The probability of each of those were 0.25, 0.5, and 0.25 again. Okay, let's first find the expected value or the mean. So the way we're going to do that is we're going to start by doing the x times p of x. That means 0 times 0.25 is 0. 1 times 0.5 is 0.5. 2 times 2.5 is also 0.5. Now because we want the sum of this answer, of these answers, we're going to add 0, 0.5, and 0.5 and we get 1. That means that the expected value or the mean is 1. So your expected value is to have 1 girl out of the 2 births. Okay? Now let's find the variance and standard deviation. The way we're going to do that is we're going to start with the formula of x minus mu squared times probability of x. Okay, so that's the second rule we gave you for variance. Okay, so here we go. My x is 0 minus my mu, which is 1, squared, times my probability of this one. My probability here is 0. Sorry, it's 0.25. So 0.25. When we solve this, this gives me negative 1. Negative 1 squared is 1. 1 times 0.25 is 0.25. Next, this one right here is 1 minus the mean, 1 squared, times the probability of 0.5. 0.5 is my probability. This is 0 times 0.5, which is 0. Finally, this one is 2 minus the mean. 2 minus the mean squared times the probability, 0.25. And that's going to give me 1. 1 squared is 1. 1 times 0.25 is 0.25. Now I want Sorry, excuse me, give me 1 second on this. Now with that, guys, I want the sum of those answers. So we're going to add 0.25 and 0.25, we get 0.5. Okay, so that takes care of the variance. The variance is 0.5. I'll just write that up here. That symbol squared is 0.5. Now to find the standard deviation, all we're going to do is the square root of that answer. So you can see that variance and standard deviation are very closely related. Standard deviation is taking the square root of the variance. And when we do that, guys, this is a rounded answer, but we get 0.7. So my answers here are these ones here, and then 1 for my expected value. 1 child is expected to be a girl. Okay, that ends part 1.